All right, so this is a quick about the idea of a function being even, odd, or neither. And so these are some examples already worked through, but in order for a function to be even, it does need to be symmetric about the y-axis. Think of that as your mirror. Now, the short story is that each x in the domain, so in this case, we've got like a 1 and a -1. If they're opposite x's, they should have the same y values, and that's for every x in the domain. Symmetric about the origin means that x's that are opposite of each other, so in this case, we've got x1, x -1, and you can see that they also have opposite y values. And then there's also some examples of functions that are neither. So again, this is from a lesson that we did just recently with 4.1. There's some definitions here about what it means for a function to be even or odd. And what I'm going to do is sort of pick up from these examples here where we're going to go through the process. And that's what I want to show here, is that if you want to show, again, not using a graph, but just want to show using the definition that a function is even, then you would need to show that the original function is the same as the function when you plug in a -x. So opposite x's would have same y values. And so let's use this example here. Now I'm going to notate this as my original function. F of x is equal to -5x cubed minus x. And if I want to check to see that if it's even, what I would do is I would plug in a -x. Again, the original function has positive x, and I'm plugging in now a -x. And so what the work looks like is I've got -5, plugging in a -x cubed, minus plugging in a -x. And so now it's primarily a job of simplifying. Now notice that this here, the -x cubed, is going to be negative because it's an odd exponent. But then when you join it with this negative, we now have a double negative. And I'm going to keep the labels for the different versions of the function. In other words, like label things, like don't not write these. Make sure you say this is my function with a -x plugged in it. Now this double negative becomes a positive 5x cubed. Here's another double negative, negative times negative, so we get plus x. So we're checking to see if this function is even. And if you take this equation here and you compare it to the equation that we just got, notice this is negative, negative, and over here it's positive, positive, which means that they're not the same. And you might just put a quick little like they're not the same, which means this is not an even function, not symmetric over the y-axis. But then what we're doing is we're going over to this, and if we're checking to see if a function is odd, then we're going to see if the equation that we just got is the same as what if we had a negative version of that equation. And so here's the way that I usually do this, is I'll take my original function, which is f of x, I'm just writing it down, -5x cubed minus x. And if I want to put a negative here, well, that means I also need to put it over the entire equation. And so you can think of this sort of as being like a little imaginary 1 here, like in front of our y value. And so we'll distribute that. Negative f of x, we'll distribute it over to here, which is going to be positive 5x cubed. And we're going to distribute that over to here as well. And so notice that all the signs have changed. And now we're taking the last equation that we had and this new equation and comparing those. And notice that they're exactly the same. I'll put a little, put a little equal sign, or maybe I'll put that these are the same, which means that f of -x is the same as the opposite of f of x. So in other words, like opposite x's have opposite y values, which matches the definition for a function being odd. So that's the work that you go through. Again, not relying on a graph, not relying on anything else, just other than the two definitions. And I'll do it again with this one. This is the George function. Again, I'm going to notate this as the original. And first we'll check to see whether it's even, which means we're going to plug in a -x and compare it to the original. So when I plug in a -x to the original function, it looks like this. And again, it's real important to keep the names. This is g of -x. And And because this is odd with a negative inside, it's going to be negative x to the fifth plus 1. And as we compare these two equations, again, we're comparing this equation to this equation here, you can see that they're not the same. One's positive positive, one's negative positive. So we would say these are not the same, which means it's not going to be an even function. Like that definition just failed right there. But now what we want to do to see is maybe it is an odd function, which means now we need to take our equation. Again, what I'm doing here is just trying to give you sort of like a step-by-step, like methodical way of, like very procedural way of like checking to see whether something's even or odd. And I want there to be a negative in front of here, but when I do this, I'm distributing a negative to every term. So it'd be negative g of x. Okay, distribute the negative. Imagine there's like an invisible 1 here. That gives you negative x to the fifth. And then the negative is also going to switch that positive to a negative 1. And so now when we compare these two, notice that we've got negative positive, and then here we've got negative negative. And so once again, they're not the same, so that it fails at being even, and it now also fails as being an odd function. So in other words, this function, it's neither even, neither odd. But that's our way of going through the two definitions to first check to see if it's either one of those. But since it's not, that's it for this. All right, so again, hopefully this helps. But when they do ask, use the definitions, your work would look something like this. But the main thing is to know that either you're comparing these two equations or you're comparing these two equations. And the first two comparison, these two, is if it's even, and comparing these two equations if it's odd. And if both of those fail, then it's a neither equation. And a neither equation might look something like this, where it's not symmetrical. You know, it's not symmetrical over the y-axis, and it's not symmetrical over the origin. All right, but I hope that helps.